In this video, we're continuing section 3.5 on inverses, and we'll discuss how we can test if functions are inverses. Okay, so I would first want to note if we have two functions f of x and g of x, they are inverses if and only if when you plug one function into the other. So like if you do f of g of x, and if you do it in the other order and do g of f of x, both of those need to be equal to x. So both of those need to simplify to just x. And that needs to happen for all the x values in their domains. Okay, so I first want to give a sketch of a reason for why this is true. So I'm going to begin by saying let's let g of x, so g is some function, and when I plug x into it, let's say that the number that I get out is y. Okay, so if f and g are inverses, if that was the case, so if this was true, what would that mean about f? Well, then f should do the opposite. F should switch the role of the input and the output. So f should plug in y, that should be the input, and the output would be x. So if they were inverses, that would happen. So now let's take a look at what f of g of x would be if this were the case. So if I look at f of g of x, well, first off, what is g of x? What is this g of x here? Well, we started off by saying let's let g of x be equal to y. Okay, so let's replace that. So g of x, we are saying is y. We are saying that g of x is y here. Okay, and do I know what f of y equals? Well, yeah. We said what f of y equals. F of y equals x. So f of y, well, that equals x. That equals x. But that is exactly what I wanted. I wanted to show f of g of x equals x. And I started with f of g of x. We simplified it, and we got it to equal x. So by very similar reasoning, I could show this other one, that g of f of x would also be equal to x. Okay, so that hopefully gives a sketch of idea for why this is true. If I have two functions that are inverses, that's only going to happen when you look at these compositions and both compositions equal x. Okay, so it's not a complete proof, but just a sketch of an idea. Okay, let's take a look at an example where we use this. So I want to test if my functions are inverses. In part A, f of x equals 3x plus 15, and g of x is 1 over 3 times x minus 5. Okay, so let's compute both of the compositions. So f of g of x would be f of, let's plug in g of x, 1 over 3x minus 5. So this whole thing in the parentheses is going to get plugged into f of x where the x is. So it's going to get plugged in where the x is. So that'll give me 3 times something plus 15. And where the x is, I will plug in 1 over 3x minus 5. I'm plugging in my formula for g. Well, now I can distribute this 3, and that gives me x, and then minus 15 plus 15. Oh, then the 15s cancel, and I get x. Okay, so far so good. When I did this composition, it did equal x like I wanted it to, so maybe I'll put a check mark here. So far so good. Let's do the other composition. So what if I have g of f of x? Well, f of x's formula is 3x plus 15. Now this whole thing that's in this parentheses, I'm going to plug into my formula for g where the x is. I'm going to plug it in where the x is. So if I do that, instead of 1/3 x minus 5, I get 1/3 times something minus 5. And I plug in that parentheses, that 3x plus 15. Okay, so now the 1/3 can distribute to each of these terms. So that gives me x plus 5, and then that minus 5 at the end. Well, then those 5s are going to cancel, and I get x. It's awesome. This one's working as well. I'll put a check mark. Okay, so my functions f and g, they are inverses because both f of g of x and g of f of x, both of them equaled x. So when you simplified both of them, they both equaled x. That makes f and g inverses. Okay, so let's take a look at one more example here. What if f of x is x squared, and g of x is the square root of x. Okay, so I'm going to look at my compositions. So first, maybe I'll do f of g of x. Then I'll do it the other way around. It's f of g of x, f of, well, what's the formula for g of x? It is square root of x. Okay, so I got to take the whole thing in the parentheses, which is square root of x, plug it in, plug it into my formula for f, where that x is. Okay, so that's, instead of x squared, I'm going to get square root of x getting squared. Okay, I'm getting square root of x getting squared. Okay, all right, and we've seen this before, but you know, when I have a square root on the inside and then the squared on the outside, they're going to cancel, and I'll just get x. I will just get x. Okay. One important thing that I want to mention about this is, well, I had a square root, so that's giving me a restriction on the domain. And when I squared it, that restriction kind of disappeared. So let's be clear about what that domain is, so I don't forget. Okay, so what's my domain? Well, if I have a square root, the thing that's inside of it, which is x, has got to be greater than or equal to 0. So when I simplified my answer and said it's x, well, that's true, but I should put a comma and include the fact that, well, x is only allowed to be greater than or equal to 0. I'm only allowed to plug in numbers that are greater than or equal to 0. Otherwise, if I'd plugged in negative numbers in here, it would have made my square root thing be undefined, and that would not be allowed. Okay. All right, so that's that first composition of function. I get x, but subject to this domain restriction. What if I do it in the other order? What if I do g of f of x? So for this one, I want to let you try it first. I want to let you try it. So pause the video for 1 minute to try this one on your own. Pause it in 4, 3, 2, 1. Pause it and try this. This is maybe the most important part of these videos, when you get a chance to pause and try it on your own. All right, let's bring it together and let's talk about it. So g of f of x, well, f of x is x squared. So I have to take the x squared and plug it into my formula for g, where that x is. So instead of getting square root of x, I'm going to get square root of x squared. I get square root of x squared. But remember that when you have square root of x squared and the squared is inside and then the square root is outside, well, that whole thing is not just equal to x. In other words, they don't just cancel. They don't just cancel the equal x. Right? We saw this way back when on, in section 1.3 of our class. When we have it in this order, it's absolute value of x. It's not just x. It's absolute value of x. Okay. Right, and the reason for that, again, remember, it had to do with the fact that, well, if you first square the x, you're allowed to plug in negative numbers for x or non-negatives, because the squared wipes them out and turns it non-negative. And that makes this whole square root thing be a non-negative value. But if I don't have an absolute value around my answer, well, this answer could be negative sometimes. That would be bad, because then it's not matching the original. So I need to put an absolute value around it to guarantee that it's non-negative. Okay, so what that means is my functions f and g are not inverses because, well, this one was problematic. This one did not just equal x. They're not inverses because my two compositions, they are not both equal to x. They would both need to be equal to x once I simplify them, but only one of them was. So they're not inverses.